All right, here we go. Solving equations by square rooting. We're going to be simplifying square roots, multiplying them, dividing them, rationalizing the denominator. We're going to be doing all of that good stuff. So the first thing I'm going to start with is basic simplifying. But to know that square roots are used in distance, answers that are not nice, like 5, areas, and all in a precise way. Now, I think you already probably know the square root of 36 is 6, but where do we get that? If we break this apart into 6 times 6, anytime a number times itself equals what's inside the square root, that's the value of that square root. All right, so here's our first examples. And if we break 128 apart, something like 4 times, what's that, 32, and this is 2 times 2, 4 times 8, 2 times 2, let's get them all on the same level here, 2, 2, 2, 2, well 8, can we break that into 3 2s? 7 2s. All right. I need 2 of something to pull 1 out. So I've got a pair of 2s here, out comes a 2. A pair of 2s here, out comes a 2. A pair of 2s here, out comes a 2. That one is left over. So I have 2, 2, 2. Now those are all going to get multiplied together, and then left over inside the square root, a 2. So my result of all this, 2 times 2 times 2 is 8 square root of 2. Over here, 28, 4 times 7. Now some people like to use perfect squares to help them square root things. So like you could stop and say, oh, I know the square root of 4 is 2. And then the 7 doesn't have anything, so it stays inside. It's 2 square root of 7. Or you can continue to break it into 2 times 2, and then you have a pair of 2s. 1 comes out, the 7 stays in. 63. 9 times 7, 3 times 3 times 7. I have a pair of 3s. 3 comes out, 7 is left over inside. You guys give these a try. All right, so hopefully you've given these a try and you have your answer. Now I know why that's gone. Okay, so I have to break this apart into 4 times 8, or it could be 16 times 2. 2, 2, 2, 2, 2, 5 2s. Pair of 2s, 1 left over. 2 times 2, square root of 2 is 4 square root of 2. Here, I've got 25 times 3. Now you could say, well, 25 square rooted is 5, square root of 3, 5 square root of 3, or you can break this apart, 5 times 5 times the 3. I've got a pair of 5s, pull 1 out, and the 3 is left over inside. Either way works. All right, 99. 9 times 11. So that's 3 square root 11, because square root of 9 is 3, and 11 is left over inside. Again, you could break that apart instead if you prefer. All right, let's check out. What about variables? When you have variables inside. So this is, I agree with you that you could break that apart into 5 x's multiplied together. Now I've got a pair of x's, I'll pull 1 out. A pair of x's, I pull another out. And that one's left over, so it stays inside. So this would be x squared square root of x. You may say to yourself, I don't really want to write out 50 x's, that seems excessive, and you would be right. So instead of writing out 50 x's, please notice with me that if I divide the 5 by 2, how many times does 2 go into 5? Twice evenly, with a remainder of 1. There should be a 1 there. And that's what stays in the remainder. So how many times does 2 go into 50? 25, with no remainder, so there's no variable inside the square root. Here, if I divide by 2, 3 divided by 2 is 1, and I'm going to have a remainder of 1 for the x power. Y, 7 divided by 2 is 3, remainder 1. And z, 10 divided by 2 is 5, no remainder, so z is not inside. Give these 3 a try and see what you get. All right, so I'm going to do this one, x to the 10 square root of x, x to the 8, x to the 4, y to the 5. I'm going to have a remainder of 1 with that one. Z to the 12, remainder of 1 for the exponent for that one. And there are my answers. Now, if you didn't quite get that, here's another one for you to try. The answer here should be x, y to the 5, z to the 75, and then you're going to have a square root of z to the first. Do you need the 1? No, but you can write it if you choose. Multiplying. If you're multiplying, you multiply outside the square root together, inside the square root together. So there's only 1 understood to be on the outside, so we're not going to write it. A square root of the 2 separate square roots can be written as 1 square root with the multiplication on the inside, like so. Now, I'm going to not multiply them together because I'm just going to break them apart anyway. So I'm going to write the 3, and then we know 3 goes into 51, and it goes in, I believe it's 17 times. Yes, 17 times. So I have a pair of 3's. That's on the outside. And the 17 stays inside, and that would be my answer to that original multiplication problem. Over here on the other side, I have 5 and understood to be a 1, so 5 times 1 is 5. And then 10 times 30 on the inside. Now as I start breaking these things apart, like 10 times 3 is 30. Oh, hey, look at that. I don't even have to break those 10s apart if I don't want to. I see that I have a pair of 10s. Now I'm going to write that 5 on the outside. And now I've got my pair of 10s on the outside. The 3 is left over inside. And the 5 that was outside times the 10 that came out gives me 50 square root 3. Okay, you give these 2 a try. Okay, here we go. Now, you could choose to multiply them together, and in this case that comes out to 100, so we know the answer should be 10, because the square root of 100 is 10. But let's do it out. 5 times 20, we know this is 4 times 5. And you can break that apart or stop there. 5, 2, 2, 5. I'm running out of room here. All right, I'll just put that down. Move this down. Give myself a little more room. I have a pair of 5s, a pair of 2s. 5 times 2, 10. Here, 2 square root 12 times 3. We know 12 is 4 times 3, and we have a 3. Now I'm going to do this one a little shortcut way. I've got a pair of 3s, I pull one out. Now I already have a 2 on the outside. I'm pulling out a 3, and we know the square root of 4 is 2. There's nothing left inside. 2 times 3 is 6 times 2 is 12. I could have multiplied these together and gotten 36. Square root of 36 is 6 times the 2 is 12. You give these two a try, and we'll do them out. All right, 4 square root 6 times 15. We'll break these apart. 2 times 3, 3 times 5. All right, so watch what happens here. I've got my 4 on the outside. I've got a pair, oops, that's not what I wanted to have. I have a pair of 3s, so 1 goes on the outside. I have a 2 left over and a 5 left over. Those go on the inside multiplied together. The end result here would be 12, 4 times 3, square root 2 times 5, 10. Over here, I've got 3 times 5 is 15, square root 2 times 10. I've got, let's see, a 10 is 2 times 5, 2. So I've got my 15. I've got a pair of 2s times 2, and the 5 stays in. That would be 30 square root of 5. Division. All right, so we're working on division now. Well, division inside a square root is the same as dividing separate square roots. So like the 9 on top, the 16 on bottom. By the way, what's the square root of 9? 3. Square root of 16? 4. If I had multiplied 3/4 times 3/4, I get 9/16. Square root of 9/16 is 3/4. Over here, I'm going to write these as separate square roots. Get carried away sometimes with my lines. Square root of 3 I can't simplify, but I can square root 25 to get the number 5. And that's where we're going to stop there. You can't have a square root in the denominator, but you can have one in the numerator. Give these two a try. So your answer here should be 3 over 8. And here, square root of 7 over the number 6. And there you have it. Now we get into something more interesting. This is referred to when we have a denominator with a square root in it. We call that irrational denominator. We want it rational. Remember, irrational numbers are numbers like the square root of 5. And it's a never-ending, never-repeating decimal. When I want to simplify or get it rationalized, in this case, I'm going to multiply top and bottom by the square root of 5. What this does is it gets rid of the square root in the bottom, and it gives you an equivalent expression. Now, 2 times square root of 5, I can only just put them together. I can't actually multiply the insides together. And then square root of 5 times the square root of 5. Now you could call that square root of 25, but the square root of something times itself is going to be what is in the original, so the number 5. Let's take a look at what we do here. Square root of 11 over square root of 3. I want to multiply top and bottom by square root of 3. This is rationalizing the denominator. The top Both the insides get multiplied together. I get 33 inside the square root. The bottom square root of 3 times square root of 3 is the number 3. And there's your answer. Over here, I like to simplify my denominators, my square roots rather, before I try to work with them. So I'm going to break this into 4 times 7. Now I know square root of 4 is 2. So this is square root of 13 over 2 square root of 7. Here's where I'm going to go for rationalizing. Now I don't have to multiply by the 2, just the square root of 7. So this gives me on top, when I multiply, let's see, 91 inside the square root. Square root of 7 times square root of 7 is the number 7, times the 2 is 14. And there's your answer there. Square root of 91 over 14. Now we have a couple more for you to try if you'd like. Give them a shot. All right, so here we go. Square root of 7 over square root of 6. Rationalize to multiply top and bottom by square root of 6. The result, square root of 42 over the number 6. You cannot reduce this 6 with this 42 because the 42 is inside the square root and the 6 is outside the square root. Now in this one, you may have gone ahead and worked with the square root of 24 over the square root of 63, but you might want to reduce the fraction first. For example, 3 goes into top and bottom, 8 and 21. Now, I've got square root of 8 over square root of 21. You might want to reduce that square root of 8 into 2 square root of 2 before you work with square root of 21, or you could wait until after. Either one works, but it's a little easier to do it when it's smaller. Now I'm going to rationalize by multiplying top and bottom by square root of 21. The result of this will be 2 times 21 is 41 over square root of 21 times the square root of 21, the number 21. Our last items are solved by square rooting. And that's what this all leads up to. So, getting the squared term on one side by itself. Now that is currently the way it is. Sometimes you have to manipulate it, get rid of addition, subtraction, that type of thing. Get rid of multiplying or dividing with the variable. In this case, I need to get rid of the 2. So I get x squared equals 16. Square root both sides. When the x or the term is by itself squared, or the thing is by itself squared, you're going to square root both sides. Now we know the square root of x is x squared is x. The square root of 16 is 4. But here's one thing you have to pay attention to. Whenever you square root both sides to solve for a variable, not when you're just square rooting, but when you square root both sides of an equation to solve for a variable, you must include this sign called the plus minus sign. So we have to include the plus minus sign. The plus minus sign just means a positive 4 or a negative 4 are our answers. Now, if we took that x squared equals 16 and we used factoring to solve it, we'd have subtracted 16 both sides. X squared minus 16 equals 0. And then we'd have factored into x plus 4, x minus 4, difference of squares. Then we'd have set equals 0 and solve. X plus 4 equals 0, x minus 4 equals 0. And when we solve, x is negative 4, or x equals positive 4. The positive and the negative 4 positive negative 4. Means the same thing, just written two different versions. This is just like a shortcut version of writing that. Last problem. What happens when you have a parenthesis squared instead of just a single term? Well, I'm going to get it by itself, divide by 4 here, or you might have had to add or subtract to get rid of it. X plus 7 all squared equals, well, in this case, 25. Now I'm going to square root both sides because I have the thing that's being squared, the parenthesis squared. So this comes out, remember the square root and the square cancel each other out to x plus 7. Square root of 25, that's going to be 5, but I have to include the plus minus sign. Now I'm going to move the 7 over by subtracting 7 from both sides. I'm going to put that before the plus minus sign. Negative 7 plus minus 5. I get two results here. One is the negative 7 plus 5. The other is the negative 7 minus 5. We know these results will be of negative 2 and negative 12. And those are the results of this problem. These two separately could be put in here and you will get the correct answer. That's how you can check it. And that's it for today.